Good morning, students. Hope you are all doing good. Welcome back to our new physics class. So, today in our class, we are going to learn magnetism. So, when we look at magnetism, we always think about magnets. We all know about magnets. What are magnets? Magnets are substances that attract ionic substance or metallic substance towards itself. We have also played using magnets. We have during our childhood days. So, can you tell certain circumstances or toys which make use of magnets? Yes, we have separated metallic particles from soil. Then we have came across fridge magnets. Then we have toys which make use of magnets. Some examples are toy cars, building blocks, and some other examples too. So, do you know whether magnets occur naturally? Do you know the story? Do you know any story behind how magnets were found? So, let us see the story, how the magnets were found. So, in 800 BC, there was a shepherd living in the place Magnesia in Greece. So, he was taking his flock of sheep for grazing. So when he was walking through the farm at a place, he got stuck. And when he saw it, he was amazed why he can move using his sandals. His sandals got stuck to certain rock. He was amazed why the rock is attracting his sandals. So when he took a closer look at it, the nails present in his sandals got stuck to that stone or the rock. So, it attracted metallic substances towards it. So, it was given the name magnets as it was found in Magnesia. Okay. So, when this rock was hanged using a coin, it showed a particular direction. So, it was named as leading stone. Later, it was named as lodestone. So, the first naturally occurring magnet is the lodestone, and it has permanent magnetic properties. So, now you know the story behind the magnet and how it was found out. Nowadays, people use magnets which are artificially made or which are created by man, or we can say man-made magnets are used by all. So let us see how these artificial magnets are created. Artificial magnets are created using alloys such as alnico. It is a composition of aluminium, cobalt, and copper. Okay, so man-made magnets are made use of alloys such as alnico. What it is? Alnico. Okay, it is a composition of aluminium, cobalt, and copper. Okay, so man-made magnets can be created in certain shapes, and it is made in certain shapes. We can see in what all shapes we create magnets. We have 5 types of magnets to study. First one is bar magnet. Second one is U-shaped magnet. Third one is magnetic needle. Fourth one is ring magnet. Fifth and final one is disc shape. It got its name due to its shape. Bar magnets are created in bar shape, U-shape magnets in U-shape, ring magnets in ring shape, disc magnet in disc circular disc shape, and needle in needle shape. Okay. So, until now we have seen what are natural magnets and what are artificial magnets. Now we can see the difference between natural magnets and artificial magnets. So when we look at the difference between natural magnets and artificial magnets, natural magnets are found in nature and artificial magnets are man-made magnets. Natural magnets have irregular shape and artificial magnets have definite shape and dimension. The strength of natural magnet is well determined and it can't be changed. But artificial magnets can be changed according to its strength, and it is easy to change the strength of the artificial magnets. Natural magnets are long lasting magnets, while artificial magnets properties are time bound. They have less usage. Natural magnets have less usage and artificial magnets are vastly used in our day-to-day life. Now we can see the properties of magnets one by one. So first and foremost one is, we have said that when the natural magnets was hanged using a coin, it showed a particular direction. So similarly, when an artificial magnet or bar magnet is hanged using a coin on a stand, it always shows a particular direction, and it is the north-south direction. Okay. So when a magnet is hanged using a coin onto a stand, it showed north-south direction. So the first property is magnets have directional property. So first property of magnet is it has directional property and it is always in north-south direction. Second property is when two magnets are brought near each other, it either showed attraction or either showed repulsion. It shows attraction when two opposite poles are brought near each other, and it showed repulsion when two similar poles are brought near. The second property is like poles repel and unlike poles attract towards each other. So let us see an video. Now let us see what is magnetic compass. Magnetic compass is an instrument used by sailors and travelers during their travel. They helped us in finding direction. So magnetic compass has a case and a magnetic needle attached to it. The magnetic needle is the magnetic substance present in magnetic compass. So the case used to build the magnetic compass is either plastic case or aluminum case. It can't be made use of iron as it gets attracted towards the magnet. So magnetic compass is an instrument used by sailors or travelers to find direction. The magnetic needle is the important part of the magnetic compass. It is the part which shows direction. It is mainly made up of plastic case, as other substance can get attracted towards the magnetic needle. So when we keep that magnetic compass on a flat surface, it always rests in north-south direction. So it is used to find direction, and the magnetic needle is free to rotate. It is independent. So until now we have seen what are magnets? Two types of magnets, natural magnets and artificial magnets. And then we have seen the properties of magnets, then the instrument used by magnets, magnetic compass, to find its direction. Now we have said that magnets always rest in north-south direction. Why it got rested in north-south direction? Do you know the reason? No. Let us see why the magnets always rested in north-south direction. The earth we live in also acts as a magnet. It has also got magnetic properties. That's why the bar magnet got rested in north-south direction. The earth magnet also has its north pole and south pole. The geographic north pole has its magnetic south pole, and the geographic north pole has its magnets south pole. Okay. Now let us see Earth as a magnet. So our Earth we live in also acts as a magnet. It was first found by the scientist William Gilbert. So when we look upon the Earth as a magnet, the geographic north pole will be having the magnetic south pole, and the geographic south pole will be having the magnetic north pole. That's why the reason the magnets always rest in magnet north pole direction. Okay, so we can say that our earth also acts as a magnet. That is the why reason magnets always rest in north-south direction. Our next topic is magnetization. How can a substance can be converted into a magnet? For that we require an axle blade, a bar magnet. So we have to take an axle blade, place it on the table and rub it using a bar magnet. It can only use one pole of the magnet. We mainly make use of north pole. So after keeping the hacksaw blade onto the table, then we take a bar magnet and using the north pole we rub it from point A to point B in a one method, and that method is called single touch method, as it makes use of only one pole and it makes use only one direction. So the bar magnet is rubbed onto the hacksaw blade only in one direction, and this method is called single touch method. After rubbing on the upside, turn the hacksaw blade and rub it. Continue the process, similar process on the other side too. So after some time we can see the point A will be having the north pole and the point will be having the south pole or the opposite pole. So after rubbing and after gaining the polarity, it can be checked using the magnetic needle. When we bring the magnetic needle towards the north pole, the south pole of the needle gets attracted, and when the magnetic needle is brought near the south pole, the north pole gets attracted. Thereby we can check the polarity of the hacksaw blade or the newly formed magnets. And this newly formed magnets is broken down into two pieces, and when we see the polarity of the broken magnets, we can see that the point A will be having the north pole and other pole will be having the south pole. Similarly for the second broken piece too. So we can conclude that magnets doesn't exist in monopole form. It always will be having dual polarity, or it will be having north pole and south pole. Monopole doesn't exist for magnets. Now let us see what is magnetic field. For that we have to do an activity. For that, let us take a paper having 30 centimeter length and 30 centimeter width. Place it on a flat surface and fix using pins. Now take a magnetic compass and keep it in the middle of the paper and mark the north-south direction. Then keep a bar magnet in the similar direction, north-south direction. Then bring a small magnetic compass near the north pole of the bar magnet and allow the magnetic needle to fluctuate. After getting rest, marks the north pole of the magnetic compass onto the paper. Then keep the magnetic compass onto the point which we marked in the center and repeat the same procedure. Now we have got many points on the paper on either side of the magnet. Now join these points using free lines, and these lines around the magnet is called the magnetic lines of force, and these are called magnetic field. Now repeat the similar process on different positions near the bar magnet and see the change in magnetic lines of force. We can say that the higher the magnetic field will be near the pole of the magnet and lesser will be on the middle part of the bar magnet. Magnetic poles will be having the higher magnetic field. Okay, whether the magnetic field lines are equal in the near the bar magnet. For that, take a magnetic compass and a bar magnet. So when we move the bar magnet near the magnetic compass, we can see the deflection in the bar magnetic needle. Now let us see the magnetic flux density. Magnetic flux density can be defined as the number of field lines passed through an unit area normally on the bar magnet. When we take an unit area on the bar magnet, the number of magnetic field lines passing normally through it is defined as magnetic flux density. Magnetic flux density is a cage-like structure around the bar magnet. Okay, so when we consider two bar magnets, we can see when it is unlike poles, the magnetic flux density can be, or the magnetic lines of force are starting from north pole of one magnet towards the south pole of the other magnet, and when it is like poles, it shows repulsion. Okay, see the characteristics of magnetic flux. The direction of magnetic flux is always from north pole to south pole, and these flux lines never intersect each other. They are parallel to each other. They are cage-like structures. They are like stretched elastic cords trying to shorten themselves. So we know that we can magnetize a substance using the process magnetization. And another method to magnetize a substance when it is kept near or present in the magnetic field is using magnetic induction. Okay, so let us know what is magnetic induction. For that, we require a bar magnet tied onto a coin and hanged using a stand and several iron nails. So first of all, we should keep the iron nail in at a certain distance from the bar magnet and see the effect of bar magnet on the iron nail. Then reduce the distance between the bar magnet and the iron nail we have taken. So when it reaches at a certain distance, or when the distance is lesser than the previous one, it gets attracted towards the bar magnet. It is due to the presence of magnetic field. There, the iron nail is getting magnetized due to the presence of bar magnet. The magnetism attained due to the presence of bar magnet is termed as induced magnetism. So we can define that when a magnetic substance is magnetized in the presence of magnet, it is known as induced magnetism. In the case of iron nail, when it was kept at a certain distance, it didn't show any attraction towards the bar magnet. But when it was brought in the magnetic field, it got attracted towards the magnet. So that property is called induced magnetism, and the process is called magnetic induction. So we have seen magnetic induction. There we have only used one iron nail and it got attracted to the bar magnet when it was kept in the magnetic field. Now bring other iron nails near the bar magnet with iron nail attached to it. There we can see that the iron nail brought again, the second iron nail also gets attracted towards the first iron nail, and similarly another pins also can be attracted to the iron nail attached to the bar magnet. It is due to the presence of induced magnetism present in the iron nail. This helps them to attract more and more iron nails towards it. Now slowly remove the bar magnet from the iron nail and see the change. There we can see that when the bar magnet is removed, the iron nails falls down from the first iron nail that was attached to the bar magnet. It is caused due to the removal of bar magnet, and it has lost the magnetism attained due to the presence of bar magnet. Or we can say that the induced magnetism gets lost when the magnet is removed. It can only be showing magnetism when it is kept under the presence of bar magnet. Here also we can attain the polarity of the iron nail using the magnetic needle. So we can say that when the iron nail, two iron nails are attached to the bar magnet, the attached end will be having the opposite pole and the farther end will be having the like poles. So when a magnetic needle is brought near the iron nail, it will show the opposite polarity. If the iron nails gets attracted towards the north pole, the attached end will be having the south pole and the farther end will be having the north pole. So when a iron nail is brought or magnetic compass is brought near the iron nail, we can say that the south pole of the magnetic needle gets attracted towards the iron nail. Thereby we can see the polarity, or we can check the polarity of the iron nail attached to the bar magnet. Now let us see the difference in magnetic induction in soft iron and steel. These can be defined using the terms susceptibility and retentivity. Susceptibility is the ability to get magnetized in the presence of magnet, and retentivity is the ability to retain the induced magnetism even if the bar magnet is removed from it. So in soft iron we can say that the susceptibility is high but the retentivity is lower. In case of steel, it is in the opposite way. There we can see that the retentivity is higher than the susceptibility. So we can define that magnetic induction is in soft iron is susceptible, but magnetic induction in steel is retentive, because the steel has the higher capacity to retain its magnetism got through induced magnetism, while soft iron can get magnetized only in the presence of bar magnet. Next we have to see is permeability. Permeability, from the word itself we can say that permeable. Permeable means it can pass through, or it is able to pass substances through it. So permeability is the ability of substances to pass what? Here in the case of magnetism we can say that it is the magnetic field. When a substance is permeable to magnetic field, it is termed as permeability. The ability of the magnetic substance to pass magnetic field through it is termed as permeability. It is most in the case of iron nut, iron nail, etc., and least in the case of plastic. Okay, so permeability is the ability of the substance to pass magnetic field through them. Let us construct an electromagnet. For that we require an iron nail, copper wire, a cell. Okay, so in order to make an electromagnet, first we have to wind copper wire around the iron nail. Then the two ends are connected to the cell, which is having the positive end and the negative end. Thereby we can construct a simple electromagnet. When the circuit is complete, check the magnetism attracting it towards the pins. Okay, so we can say that when the circuit is complete, it is able to pass electricity and the iron nail gets magnetized due to the presence of electrical. So this is called as electromagnetism. The magnetism attained due to the presence of electric source or the battery is termed as electromagnetism. We can simply construct the electromagnet using three simple substances, that is an iron nail, a copper wire, and a battery or a cell. Okay, so electromagnetism is defined as the magnetism attained due to the presence of an electric source, and the strength of the electromagnet can be increased by increasing the number of cells, thickness of the iron nail, and number of winds of copper wire around the iron nail taken. These are in the three ways in which we can increase the strength of the electromagnet. An electromagnet is a temporary magnet, while other magnets are permanent magnets.